In the previous video, I showed how we come up with this quadratic formula. And if you skipped that, that's okay. All you need to know is the formula itself and how to actually use it. So, the quadratic formula gives you solutions to any equation in the form ax squared plus bx plus c equals 0. You just look at what numbers are in the place of a, b, and c and put those numbers into this formula. The a's go here and here, the b's here and here, and the c here. So let's see how this works. Let's solve the equation x squared minus 3x plus 1 equals 0. So first we have to make sure it's set up in that form, ax squared plus bx plus c equals 0. And it is. It's got everything on one side equal to 0 on the other side. And the a would be the coefficient on x squared. So here that would just be 1. We have 1 times x squared at the beginning of the equation. The b would be the coefficient on the x term. And here that would be -3. Don't forget, if there's a negative in front of it, that comes along for the ride. And the c is the constant term, and that would be 1. So we're going to copy over this formula, but in place of the a, b, and c, we're going to put these specific numbers. X equals minus b, which is -3, plus or minus the square root of b squared, so -3 squared, minus 4ac, so minus 4 times 1 times 1, and then that's all over 2a, so 2 times 1. Now be careful, make sure this fraction bar goes all the way across. This whole thing is all over the 2a. So don't get careless and have it shrink and have only part of this be over the denominator. And the other thing you have to be careful about is the numbers we put in for b, this time they happen to be negative numbers. So if b itself is a negative number, then here where we've got minus b, that's going to come out to be positive. Minus a -3 would just be a +3. And then here where we have b squared, what happens when you take a negative number and square it? The result is positive. So be careful how you put this into your calculator or how you do it in your head. When we take -3 and square it, that's just going to be good old +9. Okay, so let's start evaluating. Like I said, minus -3 would just be 3. And the -3 squared would just be 9. 4 times 1 times 1 would be 4. Down here, 2 times 1 would be 2. There's one thing left to do under the radical sign, and that's the subtraction. 9 minus 4 is 5. So now we're looking at x equals 3 plus or minus the square root of 5 over 2. And there's nothing we can really do to simplify that any further. So we did get two solutions to this equation. One of them was 3 plus the square root of 5 over 2, and the other was 3 minus the square root of 5 over 2. If you want decimal approximations, here's how I would put this into the calculator. 3 plus the square root of 5 all over 2, and I put parentheses around the 3 plus the square root of 5 because I wanted to make sure that whole thing was being divided by 2. That comes out to 2.618 something, or around 2.62. And then, whoops, that's not what I meant to do. I meant to press second and the enter button, which is entry. So get my last entry back, and then go in and change the plus to a minus, and it's about 0.38. So the decimal approximations, the numbers that work here are approximately 2.62 and 0.38. The exact values are 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. Which do we want? Well, it kind of depends on what we're going to be doing with the answer. In some instances, we want the exact answer. In some instances, we want a decimal approximation. We want to know approximately what's the answer. Let's do another one. 2x squared plus 6x equals 11. Start by getting a 0 over here on one side. So subtract 11 from both sides, and we get 2x squared plus 6x minus 11 equals 0. So when I start plugging numbers into the quadratic formula, what do I put in for A? 2. What do I put in for B? 6. What number goes in for C? Negative 11. Don't forget the negative. So with those numbers in the formula, I have x equals minus 6 plus or minus the square root of 6 squared minus 4 times 2 times negative 11 all over 2 times 2. So minus 6, that's just a negative 6. So when b itself is positive, the minus b is negative. 6 squared is 36. And careful here, we're going to be minusing a negative. 4 times 2 is 8 times negative 11 is negative 88, but then we are subtracting a negative, which would be the same as adding a positive 88. So under the square root sign, 36 minus negative or plus positive 88 is 124. Meanwhile, down here, 2 times 2 is 4. So we have negative 6 plus or minus the square root of 124 all over 4. 124 is not a perfect square, but we can factor out a perfect square and do a little simplifying. We can break 124 up into 4 times 31. So we can write that as the square root of 4, which is 2, times the square root of 31, which has to just stay the square root of 31. So we've got x equals negative 6 plus or minus 2 times the square root of 31 all over 4. And the numerator and the denominator of this expression do have a common factor of 2. So we can reduce this to x equals negative 3 plus or minus the square root of 31 over 2. Can't simplify it any further, so there's our answer. The decimal approximations, if you want those instead, are about positive 1.28 and negative 4.28. Let's try another example. X squared plus 4x plus 5 equals 0. Everything's lined up the way it should be. Ax squared plus bx plus c equals 0. The part of A is being played by the number 1. The part of B is being played by the number 4. C is 5. Here they happen to all be positive. And when we put those into the quadratic formula, we get that x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 all over 2 times 1. Minus 4, that's just negative 4. 4 squared is 16. 4 times 1 times 5 is 20. So under the radical sign, we're looking at 16 minus a 20. Downstairs, 2 times 1 is 2. When we complete the subtraction under the square root sign, 16 minus 20 would be negative 4. So x equals negative 4 plus or minus the square root of negative 4 all over 2. The square root of negative 4. What would that be? I wonder what my calculator would say. Hey calculator, what's the square root of negative 4? Error, non-real answer. So yeah, when you try to take the square root of a negative number, that is not real. That is not a real number. There is no real number that you can multiply times itself and end up with a negative result. So depending on what we're working with here, when you see something like that, where you got the square root of a negative number, you either just, if you have to have a real number answer, you say, well, there aren't any of those, so there's no real solutions. But sometimes we want to work with the solutions even if they're not real numbers. So to be able to work with numbers like this, that gets us into the so-called complex numbers. I'm going to talk about that in the next section. For now, I'll just say that the part of the quadratic formula under the radical sign, the b squared minus 4ac, has a special name. It's called the discriminant. And by looking at what kind of number that is, that tells you what kind of solutions you could have to your quadratic equation. If that comes out negative, then you're looking at the square root of a negative number involved in your solutions. So that means that you have no real number solutions to your equation. The solutions are complex numbers involving I if you want to go there. If the discriminant comes out 0, then you just get one solution. Because instead of getting two different solutions, one when you do the plus and one when you do the minus, you get the same thing twice, because plus 0 and minus 0 give you the same thing. And if it comes out positive under the square root sign, then you do get two different real number solutions. In fact, if b squared minus 4ac is a perfect square, then you can go ahead and take the square root of that perfect square, and your solutions will be rational numbers, either whole numbers or fractions, just something over something else. If it's not a perfect square, the solutions are irrational. Now, going back to those examples I started with, we said we had to solve this equation where negative 16t squared plus 1053 equals 0. Easiest way to solve that, I think, is to subtract 1053 from both sides, divide both sides by negative 16, and remember a negative divided by a negative is positive. So now t squared equals this number 1053 over 16, and then we would take square roots. T would be plus or minus the square root of that. Although, in this case, the only answer that makes sense in the context of the problem is the one that's positive. We don't want to go back in time before you drop the rock. We want to go forward about 8.1 seconds. So since the square root of 1053 over 16 is about 8.1, that means it would take about 8.1 seconds before the rock hits the water. The other example we were looking at, we had to solve the equation x squared plus x plus 1 squared equals 2,813. I can multiply this x plus 1 squared out to start with, x squared plus 2x plus 1, combine like terms and do a little rearranging, and I get 2x squared plus 2x minus 2,812 equals 0. Everything here is even, so why don't I just go ahead and divide both sides of this equation by 2. That'll simplify things. And then I'll have x squared plus x minus 1,406 equals 0. I might be able to solve this by factoring, but I'd have to think of numbers that multiply to 1,406. I don't know that off the top of my head. Why don't we let the quadratic formula handle this for us? So I would get out my quadratic formula, and I would put in 1 for A, and 1 for B, and negative 1,406 for C. So negative B plus or minus the square root of B squared minus 4AC over 2A looks like this, which simplifies to negative 1 plus or minus the square root of, here we have 1 minus a negative 5,624. That adds up to 5,625 under the square root sign. And of course, 2 times 1 is 2. The square root of 5625 is 75. So our solutions are negative 1 plus or minus 75 over 2. If you do the plus, you get 74 over 2, which is 37. So one of the numbers is 37, and then the one that's one more than that is 38, and when you add their squares, you do get 2,813. The other possibility, when you do the minus, one of the numbers is negative 38,